Hello everybody, let's make a small game in C. It's going to be very simple, and it's going to be the groundwork for any game development that you might do in the future. So let's have a relaxed look at how to do all of that. I have very little idea of what to do myself, so lean back and enjoy. So at first I'm going to create a new directory. Let's just call it game, because I don't know what we can do in this single video. I want to load graphics in that game, ideally a background and some kind of player, and then let's see how far we can get. So the first thing that we're going to do is we are going to include SDL2, which is a 2D graphics library, and let's save the file game.c. Let me also put my keyboard on a mat so the keyboard sounds are not too loud for you. So now we can go on and create the first method. That is a simple main method. That is the entry point to the game. And it prints hello world. So let's start the software with a simple hello world. Then let's include also standard.io, which is what we need to print the hello world. And then let's compile that project. So let's go to projects, game. And if we do a compiler command, such as cc, and then output file is called game and the input file is game.c, that won't. Oh, it worked. Okay, I thought it won't work because we include SDL2 here, but since it's not in use, I think it doesn't complain. Let's try to execute the game and see what happens. And there's our hello world at the beginning of the line right here. Of course, that is not really exciting, so let's do something more interesting with it. I'm going to add the new line character, so just for you to verify that this is a proper printout and it looks good. Now this is in a self-sending line here. Righty. Then let's start some STL stuff using STL init. We're going to initialize the game using a title. Let's call it whatever. Super game. I have no idea. And let's just stupidly call it 2D game in C. Then we need a width and a height for the game window. An X and Y coordinate. I can center that application simply on the screen. So let's provide SDL window pause centered as a flag here and here as well. And SDL window pause centered. There it is. And then we pass a 0 at the end, which stands for no further flags. We could also remove the borders of the window and stuff like that, but we don't need it. And to keep the window alive for a couple of seconds, let's put a delay of 5 seconds here so that it doesn't quit immediately. Now we also need to define the flags or define the constants. Let's use a width of 900 and a height of 600. And that is it, I think. It could be that something's missing because I didn't memorize the API properly. Let's have a look at the official documentation. So SDL init. SDL init takes as input. Oh, it takes only flags as input. Of course, I was completely wrong. Of course, as always, I'm completely wrong. So we need to do SDL init, and then we provide the flags, and the flags are specifying which subsystems we want to use, and we want to generate just a game consisting of just video. We don't have any audio yet, so let's just stick to the video one. STL subsystem, no, what was it? STL init video. STL init video. Just like this. And then the second command was called, I think, STL create window. Yeah, and that looks good. So let's get that window and put it in a variable. I think it's a pointer. So let's do p window, pointer window. Yeah, okay, and let's execute that and see what happens. Now that doesn't work because we have an undefined reference to STL stuff here. So let's also add to the compilation command a linker flag to STL, lstl2. Let's see if that works. Nope, because we also need to link, I think this one, LGL. Oh, again, I forgot the API. So STL2 compiler flags. Let's have a look. We can use those flags right here. Let's see. Okay, but it seems that nothing is happening. Why is the window not opening? I'm creating a window here with the specified width and height, and I was specifying a wrong flag here. Maybe you caught this before me, but here I specified STL window pause centered mask, which is wrong. We have to use STL window pause centered, just as the other flag that I used over here. So this is a simple typo, and now it should work. Let's see. No, it still doesn't compile, or it does compile, but it doesn't open the game. Why? Maybe I mixed up the width and probably that's what the issue is. Probably width and height have to be passed after the window flags, after the position flags that center the game. So let's try that. And indeed, that is the game window right here. Yeah, sorry for the confusion. If you are unsure about documentation or about API, always look it up. Don't do it like me and try to remember everything, because it makes your life harder. So you could have, or I could have looked up STL2 and then create window, and then the first result would be this one, which specifies the variables that I have to pass to this function. But of course I didn't do it, so it's my fault. All right, so we have a window now, and now I want to create for the first time ever an STL renderer, which is using, well, an STL renderer is a tool to use the graphics, card to compute stuff on screen. So far I used always a very old-fashioned approach and manipulated STL surfaces and pixel values directly, which of course doesn't make any use of the GPU. And now, because we want to properly load stuff in a real game that is going to be a real game, maybe this is going to be the next GTA 5 or GTA 6, that's the thing that I'm developing right now, and we all don't know it yet. Depends on you. If this video explodes, then I will put some effort and make this the next. I will make this GTA 7. All right, so we are creating a renderer, which is a tool to use the GPU. So let's look for create SDL2 renderer, create window and renderer. That sounds good. Oh, there's a common function to create both a window and a renderer. But for that we have to pass in a window variable pointer to a pointer and then SDL. That sounds too complex. Let's do it separately. There's a create window function and then there's the create renderer function. So let's look it up here. So here we're creating a 2D rendering context for a window. Okay, that sounds good. Let me just copy that syntax here and just paste it in my code. Let's give it some space in the code so that we can have a comfortable look at this. So the return value is a renderer pointer. Let's call that p_renderer. Then at the end of the line, let's remove those spaces right here. And as input, the first input argument that is accepted or expected is a window pointer. So let's pass our window pointer variable. And then we have an index and flags. Let's have a look at what those are. The index is the index of the rendering driver to initialize, or -1 to initialize the first one supporting the requested flags. Well, then let's just pass -1. I mean, I don't want to bother with the low-level details and I have no idea what drivers I have, what rendering drivers I have. And then the flags are 0 or 1 or more SDL renderer flags ORed together. So let's have a look. There's the software renderer. Okay. The renderer is a software fallback. Then we can use hardware acceleration. Then we can synchronize something. We can use a vsync renderer. And then the last one is the renderer supports rendering the texture. I don't really care. The only thing that I read on renderers before I started recording this video was that renderers are useful when creating something that uses the GPU properly. And that means I want to have an accelerated renderer. I don't want to have a software solution here. So let me just try to pass that as a flag. If it doesn't work, I will just remove the flags and just pass 0. Then I don't care. All right, and that is our renderer. Let's execute the application. Of course, this is still black. And there's nothing to do in the game yet. But let's have a look. And the fact alone that we don't have an error message is already very, very promising. That means we can continue. And the next thing that we can do now that we have a renderer is work with it. And I think it might make sense to look up the category render in the API specification. And here we can see what the renderer does. So we have 2D rendering functions and we can manipulate single pixel points. Okay, good. We have single pixel lines, also useful. Then filled rectangles and texture images. And what I want to do is to load texture images, just as in a real game where you have textures. So let's look for text. And there's a function create texture, which sounds promising. Then there's create texture from surface. We don't have a surface yet. Surface is what you use if you normally work without a renderer, if I'm not completely mistaken. But let me open that as well. Yeah, we don't have an existing surface. Let's just forget about this. Let's see the next search result. Destroy texture. Okay. Some scale modes, get texture user data, bind texture, unbind texture, log texture. I don't know the programming patterns that are used when working with textures, so all those binds and locking, I have no idea exactly how and when to use those. And the only thing that I care about is create a texture. And I want to have a texture. Yeah, okay, the texture will take as input my renderer. We already have a renderer, that is good. Then we specify a format. I don't really know, I don't really care. I would just want to provide an image. The access integer, what is that? It is one of the enumerated values in SDL texture access. Okay, we will have a look at the format and the access in a second. And then we specify a width and a height. And the return value will be a texture. But this is not really helpful for now because I want to load an image. And I don't see any entry point for an image here. I mean, because we specify a renderer and a format and an access integer and a width and a height. Okay. And this gives us a texture pointer. Maybe this is some space where we can load an image into, but I have no idea. So let's look up load SDL2 image to texture or something like that. And indeed, there's a function. And there's a function that is called image_load texture that loads an image from a file system path into a GPU texture. Very good. GPU is what I needed. GPU is what will result in an awesome game, GTA 7 style. Just joking, of course. Then we have this syntax here. We specify a renderer and a file. Oh, that sounds very, very, very promising. So let's just copy that, and I would expect this to give me some kind of access to a simple, in-game image that is loaded on the screen. Let's see. So we will specify this texture. Let's define the name of that, p texture, maybe p player texture. No. Let's call it p texture. We will narrow all this down later if we need it. Then we specify the renderer, p renderer, and a file. Let's have a look at how the file is defined. It's just a file name. It's a constant character pointer, which in simple terms is a string. So we can just say sprite.png, I hope. I don't know if it accepts PNG files, so the simple image files. But the documentation is just a path on the file system to load an image from. Now, because this is SDL and SDL is very low level, I could imagine that this accepts only bitmap files or something very low level. But it seems that there is no restriction here. So what are we doing? We are loading an SDL texture, which represents an image in GPU memory that is usable by SDL's 2D render API. Sounds good. This can be significantly more efficient than using a CPU-bound SDL surface. Yeah, that's what I was talking about, and that is what I was always doing in the videos here on this channel. But if you don't need to manipulate the image directly... wrong pronunciation. This can be significantly more efficient than using an SDL surface if you don't need to manipulate the image directly after loading it. Okay, so efficiency is awesome. That means we are going to use that. And now I just need some kind of texture. So let me just go to... let me just look up GameSprite.png. What is a good game sprite that I can use? Should we draw our own? What if we draw our own? Let's see. This is a DIY project. Let's scale the image down to a size of maybe 50 pixels, and vertical will be 100 pixels, something like this. This is our sprite, but somehow this is kind of squared. Wait, no, 50 pixels. 50 pixels by 100. Let's see. Okay. And maybe this one is too narrow. Let's do 65 by 100. Even worse. I feel like I'm misusing paint here. 75 by 100. Okay, that might be fine. Let's pick a brush and let's draw our sprite. I have never drawn a sprite, so this might turn out to be horrible. Let's start with some nice grayish background. Is there some way to... we could use the shapes. What if we use such a marker? Yeah, that is much more pixely. So, no, it will overlap the colors here. No, this is not good. All right, let's use this brush. And let's give it a big face. Big face, come on. Just like that, or a big head. Awesome. And then let's do the following. Let's give it a big mouth as well. Some teeth. Maybe the teeth are not a good idea. I don't know. This is really the first time I'm trying to do something like this. And let's paint the mouth red. And then give it some big, generous eyes. This dude looks crazy. Maybe like this. Give it a bit of different size here. And then the pupils can be very big as well. The right ones are a bit smaller. Okay, that looks good. Then let's give our character a body. I will give him a green shirt. And maybe gray legs and arms again. Maybe something like this. He's odd. He's really odd. But okay, let's save that file. It's good enough for now. Maybe let's give him some more details so it looks cooler on the screen when he's finally loaded. So let me just do. Oops. Let me just give him a sword. Just like that. And of course the sword has highlights, such as some glow. Oops. All the graphic designers that are watching this are probably going to freak out because this is so horrible. Let's put some colors here and here. And maybe put some white in the center of that sword. Just like this, to indicate that this is a good item. All right, okay. And maybe let's add also some highlights to the green and make the center of that body a bit brighter, just so it looks a bit friendlier. Okay, I think that's fine for a first time. And let's save that as a, we can even save it as a bitmap picture, which might be useful for STL. Let's save it as a PNG for now, because this is probably the most accessible format for all of you. And let's go to the directory that is running, that is where this C source file is stored, and it's in Explorer. And then we can pass the current directory or the current file name and then the parent directory of that using the :h. So now we should, yeah, that's how it works. Then let me just save that file. Let's call it sprite.png. And now let me just move the file over. Oops, I misclicked, sorry. Give me a couple of seconds. And there we go. So we have this C file here, the source code, the game itself, and the sprite. Then let's go back to the code and see how we can continue here. Actually, there is no need to do something now. I think the texture is going to be loaded. I don't know if it's going to be rendered on the screen. So we have passed the renderer as input to this function and the sprite name. So let's run the software. And there's an error, of course. We misused a function. Yeah, it seems that the image load texture function is not available. And I was already surprised by this image load texture function because it is prefixed with image instead of with STL. So probably we need to embed some other library as well. Let's have a look. Okay, here it says this function is part of STL_image, a separate library from STL. Let's have a look at that. STL image. But it seems to be part of STL itself. So maybe we can resolve that problem by just including STL_image as well. And it seems to be the case that this is not found. Okay. This means we have to somehow make it available. STL2, STL_image. Let's have a look. What is STL image? This is a simple library to load images of various formats as STL surfaces. Sounds good. It can load bitmap, GIF or GIF, JPEG, LBM, never heard of that, PCX, never heard of that, PNG, and all the other formats. So that sounds very good. It can even load simple SVG, vector graphics. Very useful, very useful. But now we somehow need to work with that library. It is available at GitHub here, and we can download it here. There's STL3 image, but we but we're using STL2. Will this result in some kind of conflict? What about STL_image? Is there something like this? No. STL image is a library that provides image decoding for many popular formats for simple direct media layer STL. Okay, this is STL image 3.0 right here. I don't want STL image 3, of course. I need 2. Yeah, this is currently the STL image library for STL3. I want it for STL2. So let me just look at how I can find it best. Let's just get the release 2.0.0. And there's some source code that we can download here. Let's copy that link and download it to our projects directory using wget. Let's paste the link and it's downloading. And then let's extract that. And there it is. So let's go in here. And then we can probably do make. No, we can't. I'm really bad at understanding how to install all these dependencies. So let me just try to find out how that is to be used. Oops. So apparently there are a couple of C files here. There is a make file here, but it's makefile.am and makefile.in. No idea how to work with that. Probably one of you knows. gccfat.sh. What is that? Build universal binaries on Mac OS X. We don't need Mac. What does the install sh do? Okay, let's do bash install sh. No input file specified. Well, is there a help flag? Oh yes, there is. This is absolutely cryptic to me. No idea how to use that. Installations instructions and a quick introduction is available at install_md. Let's check that. Is there a README? Yes. Okay, this is a this doesn't contain any installation hints. Anyways, let's have a look here. We can use cmake. The easiest way to use STL image is to include it along with STL as a subproject in your project. Yes, of course. Create the file cmakelists.txt. Okay. What if I do cmake? Nope. How to install STL_image. Oh, we can even install it as a package. If that works, then of course all that cmake and repository downloading was unnecessary. All right, let's see. Can we compile now? We still can't compile. But let's have a look at how to embed it. Maybe we have to remove the SDL2 specification here. Nope. SDL2 underscore image include. Include SDL image.h. Okay, so it might be correct to include SDL underscore image.h, but then we also have to link that. So let's also link SDL underscore image. No idea if this works. Of course it does not work. I'd never know how to know what to link. Ah, there's SDL2 underscore image. Okay, let's see if that works. SDL2 underscore image. Nope, doesn't work. Let's have a look here. What are those compiler flags? Let's install that. I feel like I'm really bloating my system here. Okay, let's try. Let me clear the screen again. This was completely unreadable. Package SDL2 image was not found in the package config search path. What about SDL image? Ah, this one worked. Okay, then let's also specify those flags by saying that we want to compile the game, and we specify the flags with backticks here using package config cflags SDL underscore image. That doesn't work. But it seems that the library is now at least found, I think. Is it found? There's an error that says redefinition of struct SDL version. So maybe that SDL underscore image version is not compatible with the SDL version we use. Or is it include SDL? I include SDL here. What do the other flags resolve to? They link SDL2. Maybe that is a conflict. Because here we include SDL and here we include SDL2. I don't know. Including SDL2 and SDL2 underscore image with CMake. Have I even downloaded SDL2 image, or have I downloaded SDL image? What have I downloaded? SDL2 image. No, I have installed image 1.2. libstl2 image 200. That must be it. Let's install that. Oh, this is so confusing, huh? This is one of the biggest problems I have with C. C is awesome if you do small programs, but as soon as you embed libraries, you really have to know what you're doing, and I never know what I'm doing. So let's try to compile this with the following flags. Here, this is the command. I'm just changing the C flags and change SDL underscore image to SDL2 underscore image. And there's an error because we're embedding SDL underscore image. Let's do SDL2 underscore image here. And let's try again. No. Does it need to be SDL underscore image? I have no idea. SDL2 slash SDL underscore image. No. Okay, let me try the C flags again when we use SDL2 underscore image. That package was not found. Why? Because I expected to have it installed using... no, I have to install that with... Wait, I have to install libstl2. Image dev, not image -200. Let's try that. Oh god, this is so embarrassing. All right, let's try again. Oh, and now we do have working SDL2 image flags, and it seems like they use the same flags as before the SDL2 itself used. Let's just confirm. Yeah, it looks exactly the same to me. Yeah, so let's just remove the SDL2 specific image flag. So all we actually had to do was install the proper SDL2 underscore image package dependency. And now I would expect this to work. Let's see. No. Undefined reference to image load texture. Damn it. So let's look up SDL2 underscore image load PNG. What? Let's just see what happens. So this is SDL image 2.0. Where have we looked up this function? Create texture was not it. We had it from here, from image underscore load texture, but this sounds actually promising. Defined in SDL underscore image. And SDL underscore image is here. Do I have to include this differently? Maybe. No, but it should also be fine. Why does it complain that no such file or directory is found at the very bottom of the screen? What if I put it in parentheses? No, are these parentheses? They're called quotes. That doesn't make a difference. SDL2 image underscore load not found. Are the linker flags really different? Let's have a look again. SDL2 image looks exactly the same. What about SDL image? Can I list packages somehow here? List all. Okay. List all. Grab SDL. Okay, we have SDL2 and we have SDL image. So package config SDL2 cflags SDL image. Cflags SDL2 image. They look exactly the same. I don't get the difference here. What if I just manually add my compilation flag, my linker flag SDL2 image? Oh, then it works. That's odd. So somehow, please explain it in the comments. I have no idea why this is happening. Somehow, when asking the package config here for the cflags that we should use to get SDL2 image running, it does not specify itself. So we have to add itself manually to my compilation command here. I don't get this, but okay, it seems to be working, so let's just forget about it. We have a black screen again. Awesome progress. Awesome progress done in this video, really. Why do we have a black screen? At least we don't have an error message, and that is already awesome. So that means something invisible happened in the background and the texture is really loading. Now, what I'm missing is we probably have to get the renderer or somehow the window or what, I don't know what. We have to refresh something and tell the SDL library that it can draw now. There's an update texture command, but that might not be it. So let's just scan the available functions for the renderer here again. There are different drawing methods here. So we have this window, we have the renderer. Technically, we could update the window or the renderer. We don't have access to anything else, so we have to update the window or the renderer. There's no other option actually, except if I'm mistaken and I don't know what I'm doing. Good. So SDL load image. Let's just look it up. Let's look up what code other people wrote here. Here someone creates a texture from a surface. Okay, that results in a texture, that is fine. And then they call SDL free surface. But I don't think that visualizes the surface, does it? Let's have a look at this code here. We create a window, that is fine. We have to initialize PNG loading. Huh? Why is that? And how could I have known that? It's specified nowhere. Or is it? Alright, let me just look up the SDL load image documentation here again. Here we load an image from a file system path into a software surface. Ah, no, that's not the one that we used. We used the SDL2 image underscore load. Load an image from a file system path into a software surface? No, that's not it. Am I stupid? Ah, there it is. My image load texture. Here we load the image into a texture. Now, How do we visualize it? Let's check. SDL2, display, texture. Okay, there's someone explaining everything that I that I just found out by force. Awesome. Oh, it's somehow getting dark outside. My webcam is even getting darker. That's reflecting the mood. Oh, everything is bad mooded. No, there's a storm outside right now, and it's getting dark. Let's see if the clouds break up again. In the meantime, I'm dark. So here someone loads a texture. That is fine. Into an SDL texture. Why did I even use image load texture and they just used this? Probably that file is not supporting many file formats. Let me just turn on the lights. Oh, this is horrible. Oh, this is much better. All right. Then we do render copy. Okay, we create a texture variable. We have one. And image load texture, or our alternative that we use to load from a PNG directly, has the ability to load a picture and immediately convert it into a texture. That's fine. It asks for your renderer, since the renderer is the one that would work on it. And it also asks for the file name. Let's say your file's name is texture.png. Then you just input that in that area. The file should be placed inside the folder that contains the other header files. Yeah, okay. The header files? I should put the image where the header files are? No, where the source files are. That doesn't make sense to me. Why should it be where the header files are? Now just loading it. Wait. Okay, let's do a small experiment. What if we change the sprite name to sprite2.png? What is even the file name? I forgot it. It's sprite.png. Okay. Then let's compile and run. And there's no error message. So we don't know if the program even successfully loads the sprite. Of course, that's not good. Now our texture should display the top left corner. Wait. Now, just loading a texture won't give you power over it. What you want now is to gain control over it. That's why we create a rectangle. Now, our texture should display the top left corner, since the coordinate is at 0, 0 and should be 50 by 50, which would make the texture be shaped like a square. What? We create a rectangle, so creating a rectangle is meaningless. It's just passing coordinates and width and height. What does the rectangle do? It specifies where the textures to be rendered, I guess. So let's copy all of that and try to replicate that. Oh god, it's raining really hard. I have to close the window. And I'm back. Ooh. I really like thunderstorms. They are awesome. They make it much more comfortable to code. You probably know that. The worse the weather is, the better it is to sit inside and just code or learn something, do something that interests you, that genuinely interests you. If you sit at bad weather at home and you waste your time, that's not as well spent as sitting with bad weather at home and you spend your time really well with something that genuinely interests you, not with some stupid distraction. Okay. So we are. God. I wish you could. Oh my God! I wish you could see the storm right now. It's raining like at this angle because the wind is so strong, and it's hitting my window. Okay, forget about it. Let's copy all of that and paste it here. And try to understand what it's doing. I'm just moving it or adapting the indentation level. So here we clear the renderer. Okay, good. That probably means what does that mean? Renderer clear. SDL2 renderer clear. Oh, it's right. Wait, I forgot a window. Okay, I had to dry the floor because it was raining into my apartment. Awesome, great programming video here. But okay, so STL renderer clear. Then we do renderer copy. We provide a texture rectangle which specifies, I think, the location of the texture. So let's just specify that texture rect, and that is equal to a rectangle struct stl rect, and let's pass some coordinates. Let's say 50, 50, and it's 75 by 100. Because that's the dimension of our rectangle, so we specify its coordinate x equals 50, y equals 50, width and height are 75 and 100 respectively. Then we clear the renderer, we copy the texture at the texture rectangle, and then we render present. Aha, that's what I needed. Okay, what does renderer clear do? Clear the current rendering target with the drawing color. Okay, we haven't specified a drawing color, so I think it's black by default. And then we do renderer present or render present. Update the screen with any rendering performed since the previous call. Okay, awesome. So let's see what happens. And it doesn't work because I misnamed a variable. And that is this right here. We use p-texture instead of just texture, because by naming convention, by the Hungarian notation, you can look it up, Hungarian notation, just like the country Hungary, we prefix any pointers with the p to better be able to understand the code. And still I forgot to update the renderer name. It's p-renderer. Then this renderer as well, this one as well. And that should be it. Let's see. And there's our sprite. Awesome. Now, actually, this is really awesome. This is really damn awesome. It's damn ass. It's damn awesome. That's awesome. I never visualized graphics in C. So what I think is missing, or what could make it a bit better, is if the background was white, because it's a happy game. And of course, the sprite itself has a white background as well. We could remove the background, of course. But let's keep it simple. Let's make it the renderer. Let's set a renderer draw color. STL set render draw color. Okay, let's copy that function. And I think if we set that, we update that color, then that will put the background to be white by default. The input is a bit weird. I've never seen in STL that the color is specified with RGB and A separately. Usually they use for colors the uint32, which is all the colors in one integer combined. But okay. So we set the renderer draw color. Then we provide the p renderer. Then we set RGB. Because we're dealing with white, it's going to be 0xff, 0xff, 0xff. Those are hexadecimal 255 values, I think. And then the alpha should be 0xff as well, because that means that the color is fully visible. It's fully visible. Yeah. Usually opaque? No. Wait, is 255, does it mean it's completely opaque, or does it mean it's white? Okay. Awesome. Awesome. It's working. Okay. That means now that we have a sprite, can we make it bigger? How does it look if we completely deform it? Let's have a look. Does the renderer deform the image? Yes, it does. Okay, that's awesome. That's awesome. That's so really awesome. Let's scale it by 2, just to have it bigger on the screen. That's the sprite. Nice. Okay, what can we do with it? We can now probably move it around on the surface. So here's the texture, here's the rectangle that defines the location of the texture. I think if we adapt the location of the coordinates in the rectangle, let's try this, then the texture will be in a different place. Yes, okay, very good. So that means we have understood correctly what we're doing. Then let's do a game loop. So the application is not quit while it's not quit. While not quit, we are looping over. Oops, we are looping over. That's actually quite fun. I really enjoy or love, I actually love that I finally got to render real textures on the screen. This is really nice. I always coded everything by hand, and now we can just draw images in Paint or Photoshop or whatever image software you use, and you can load it in STL. It's actually quite powerful. That means that if you can make simple rectangles bounce around in the game, then you can also then you can basically already make a game. If you just replace the drawn rectangle with a sprite, with a texture that you loaded from an image. All right, so let's check if the game is being quit using an STL event And let's poll events here, SDL poll event into the address of event, and then we check the result. Because if the game is quit, if the event.quit, let's check the API again before I mess anything up. SDL event. So an SDL event can be anything. It can be a display event, a keyboard press, some kind of motion, some button, whatever. And I want to check for the quit event, which is this fields. So let's look up the quit event definition. And the quit event dot type must be SDL quit. SDL quit type is equal to SDL quit. And if that is the case, then we set quit to true. That means that the application quits when we press the quit button. Awesome. Something's wrong. I think I missed a quote or yes, there's a missing bracket or brace or parenthesis. Wait, I always mix up the names. Bracket, brace, parenthesis. Okay, parentheses are round, brackets are cornered, and braces are curly. Okay, good. All right, now the application stays open as long as we are in the game, and when we press the exit button, then it closes. That's really, 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 really nice. Awesome. Okay, now what we can do is we can probably introduce some small delay so that we don't overuse the GPU. SDL delay. Probably I'm still doing some mistakes here, but anyways, 20 milliseconds should be good. That results in a frame rate of 100 frames per second, and that's it. Now, is this a game? No, it's not, because we're not moving around on the screen. So let's check in the events also for if the event is a keyboard event. Let's look up keyboard events here. Yeah, keyboard event is .key. So let's look that up. Oops. And the type is SDL key down, of course. Dot type equals SDL key down. And then we check if the key that was pressed, the key symbol, event.key.key sim, and if that is an arrow key, probably an arrow key. Let's look up the key sim definitions. If we have this key symbol, key code symbol, oh god, keysim.sim. Okay, let's look up the key codes. What are they? I just want to check arrow for the arrow keys. Key code arrow. How to use SDL key code to handle a key press each time. Okay, nobody really answering. Okay, it seems to be some constant, and we can compare this with... Okay, there are constants for different buttons. And I would expect some arrow key here. Okay, here's the up arrow key. Okay, then let's use those. So if the key.keysim.sim equals SDL scan code up, then what do we do? We move the rectangle up. Let's try. So let's pass an X and a Y coordinate here. Width and height are already passed. Oops. And X and Y start at, in X, let's say it's 50. Or let's say 250. And Y is also 250, so it's somewhere in the center of the screen. If we press the key code, the scan code, the arrow button up, the up arrow button, then what happens is we decrement the Y value by, let's say, 1 pixel. Okay, then we could probably just do Y minus minus. And then the same thing if we press. By the way, we are using Y minus minus, even though we're moving up, because, oh no, I just deleted my sprite. Did I? I deleted my sprite, but, oh no, that must be a really good explanation. So this is the coordinate system on the screen. From SDL's perspective, this is X and this is Y. So Y is pointing down. That means if we increment Y, the sprite here is moving down. If we do plus plus. But if we do minus minus, then it's moving up on the screen. All right. And if we press the scan code down, then Y should increment. And similarly, let's copy those again. If we press left, does that exist? Yes, it does exist. Then we decrement X, and if we press right, then we increment X. Okay, that's some very, very, very basic pixel-wise movement here. Then those variables are passed into the rectangle here. The renderer is cleared. We actually only need to clear the renderer if we perform some button press, let's say here. Oops. Because otherwise we don't need to redraw every time. Yeah, and similarly we also need to update the rectangle only after we press a button. Similarly, we only need to present the render stuff inside those controls. Okay. And it's black now. Great. Of course, that doesn't work if we never press a button, then nothing ever happens. So we need to initially draw all that stuff up here as well. And let's see if that works now. Okay, this is our sprite, and let's move the sprite. And nothing happens. Damn it. Why? Probably the key presses are not being logged. Let's log the key events. Printf key pressed. Because if the key presses are being logged, then I would expect those. Then I expect the renderer to be updated. Let's see. Yeah, so the key is being pressed and that is logged to the console in the bottom right corner, as you can see. So that seems to work. Somehow the texture doesn't update. We are creating a new texture rectangle here. Is that wrong? Maybe it makes sense to also print the values of x and y. So let's do the x equals this and y equals this, then a new line, and we will pass x and y as inputs to the print statement. So let's try. If I press up, okay, the coordinates don't change. Why do the coordinates not change? Probably because those if events and those if statements don't evaluate properly. So let's check again. The keySym dot symbol. What is that type? KeySym dot symbol is an SDL key code, and the key code has a scan code value. Okay, that doesn't really fit together because here the keySym variable or structure contains a scan code and a sym, but I'm checking the sym. Maybe we need to do the scan code. Scan code. Let's just try. I'm not sure if that is the best practice, but I think this might work because we're checking for the scan codes in the constants on the right hand side of the if statements. Let's try. Yeah, and that works. Okay, so let me just press the arrow key, and as you can see, our player is slowly moving up, and now it's moving to the right. Yeah, but it's incredibly slow because we're just incrementing the position by individual pixels. Of course, that won't do it. Let's do +10 and do the same here. Wow. Plus equals 10 plus equals 10 and plus equals 10 here. And let's try again. This is our figure. Let's move it. Oh, and regardless of which, somehow something doesn't work. If I press the up key, it moves down. But I wanted to move up. Oh, I'm stupid. I'm so stupid. Why did I write plus equals 10 everywhere? That's when your brain just shuts off and you do something so unintentional that you completely forget about all the logic that you want to follow. So this, of course, must be a minus equals 10. Then moving down is plus equals 10. Moving left is plus equals 10. Moving right, no, moving left is minus equals 10 because we're decrementing the x coordinate. And moving right is plus equals 10. Okay, very good. To be honest, guys, this is one of the best videos. I'm enjoying this so much because I really like that I really like, and I enjoyed so much that we're really drawing real graphics on the screen in C. And this is so visual. This is so nice. We have this stupid little sprite here, and it's moving however we want to. Isn't this awesome? Of course, we could now make a jump and make it, give it some more sophisticated movements, but this is already awesome. So we can walk around with this little figure. Let's move it a bit faster. Like this. This is so nice. Okay, and one more thing that I would like to do is to give all of that a background. And to do that, we can use Paint again. Now let's do not save. Let's create a new image that matches the dimensions of our STL window. That is 900 by 600. just like this. And let's give it some, oh well, where should we put our stick figure? Maybe we give it some green grass or something. Let's make it a very light tone. A very light tone, because that's just the background. It shouldn't dominate the screen so much. Something like this. Okay. And then we provide, or we draw a, we draw a background, just like this. Something like this. Some clouds here. Let's stylize them a bit and make this our game style, that the clouds are so straight. Let's put a big cloud here on the right hand side. I feel a bit like Bob Ross right now. Something like this. And then we can do, what can we do now? Yeah, let's just save that as a background. Background.png. And let me just copy that over. Here, so this is now our directory. We can remove all the imported stuff that we did before, the SDL libraries, the SDL image libraries. Okay, we can't. Let's forget about it. So we have the game code file, we have the sprite. Those are our files. We have the code file, we have the compiled game, and then we have the sprite and the background. Okay. Then let's render the background. We can probably just do the following. We can do, the first thing that we're going to render is the background. Oops. Just like this. Render background. And let's give this a comment as well. Game loop. This is the loop where we're checking for events and where we're updating the stick figure's position. And this is the background rectangle. And it starts always at 0, 0, and it matches the screen's width and height. And we're I'm rendering this outside of this game loop because we only have to render this background once and then never again. Hopefully, at least this is my understanding of the SDL renderer. Now I don't know if we have to create a new renderer for the background only, or if the same renderer can do the background and the sprite, so the player. Let's just test it. So we have the renderer clear here, renderer copy, and then also SDL renderer update, or what was it called? Renderer present. We also need that one. Okay. So we are passing as input the p texture. We haven't defined the texture for the background yet, so let's do that here. P texture background. Image load texture, and we need to load the background.png. And then when we do render copy, we do p texture background. That's a null texture rect. Okay. P renderer, p texture background. Okay, the texture rectangle has of course also to be updated. Background rect, like this. And let's try to run the game, and it doesn't work. And my best guess is that we need separate renderers for the separate items. Because here we're clearing the renderer. We're telling the renderer it needs to render the entire background. And then it renders the background here. And then later we are rendering a completely different thing down here. Yeah, and maybe that is overwriting what we did before. So let's create a separate renderer for the background. P-renderer, background. Okay. Now I know this code is a horrible mess, but I just want to get this working. It's the first iteration of our new world-changing game. So we create a new renderer here. No, we have already created it. Now I need to go to all occurrences of p-renderer and suffix them with background for the new renderer. Oops, like this. Oops, like this. And here, like this. Okay, let's try. Oh damn, it doesn't work. Why doesn't it work? Render present. Okay, the problem is I don't know how to render different items or different images at once. The file is called background.png, so that shouldn't be the issue. Then we have this background rectangle, which defines the full background. We clear the background here. Okay, let's look this up. SDL2, render multiple images. You pass an image or other format, image.png or other format onto a texture, then you place the texture on a surface, which is then passed onto a renderer. Okay, so all you have to do is change the clip and texture and pass it to the renderer in the right order. Maybe the issue is not that we need a separate renderer, so let me undo all of that again. Yeah, so now the renderer is gone. I'm using only p-renderer here, so we're using the same renderer. Maybe the issue is that we're clearing the renderer in between. We just need to copy this stuff. We don't clear the renderer, we only clear it. No, it needs to be cleared at some point. But let me just remove all of those statements, and we update, or we call renderer present only at the very beginning, before any button is pressed here. Then we also present. But we don't clear before. No, we don't clear here. We clear before I render the background here, or before we render the background. Okay, we clear the renderer. That erases all data. We don't have any data at the beginning, but let's just do it for completeness, just to keep our thinking clean. So at the beginning, we start with a clear renderer. We put the background texture on top of that. Yeah, we put the background texture on top of that by calling render copy, and we copy the data into the renderer. Then we put the sprite into the renderer here, and then we present the data. And when we move the figure, then the renderer shouldn't just clear the entire screen. It should also, of course, redraw the background. So I would expect as soon as we hit a button to have a white background again. Let's see. Yeah, there's our game with the background. Super nice. Now we move the figure and the background is white again. I don't like the background actually that much. I don't like this gap here where you can see a bit of blue. So let's just do something like this. I'm not good at drawing clouds. Okay, file is saved. Let me update that file. Okay. The file is updated. Now, this is how our game looks like. It looks pretty bad. And when we refresh and move the player, then of course the background vanishes. We can work around that by not calling render clear. This will, however, cause the following issue. When we move the stick figure, then it will not clear the old images, which is quite nice to visualize here. Awesome, this is so interesting. And when we do clear, we also have to draw a new background. So we do this. We render the we copy the data to the background using this. Maybe I should put this in a function. No, let's just do it hardcore. Render copy, render clear, redraw the background. Redraw the background. Draw background. Or let's say redraw background. And then redraw player. And let's see. And now we can move around. We can move around the game and it looks decent. Now, of course, the issue is that the player sprite still has a white background while the actual background is filled, and this looks very cheap. So we have to remove the background in our sprite. Let's do that. Can I save the transparent background in Paint? Or can I make a transparent background in Paint? I don't know. Let's just copy that file over to Paint. So here's our sprite. Now, can I somehow remove the white background? Transparent selection. What is that? No. Transparent. Okay. Paint, remove white background. Use the remove background feature if available, or utilize the select tool with transparent selection and freeform selection options to isolate the desired area. Okay, use the remove background feature. Let's see if I have it. Here. Did anything happen? Ooh, no. Is the background not transparent or not? Oh god, this looks horrible. Okay, let's do a freeform selection. It's probably not so precise, but to just get the point across. And then we can remove the background. No. Let's forget about Paint. I'm going to use Photoshop. Oh my god, what happened to my stick figure? Oh, it looks crazy now. I don't know what it did. So, this is my Photoshop instance. Let me just draw the sprite into that. And there we go. Let's zoom in and remove the background just using this magic wand right here. And then let's add this inner selection as well. Let's add this part, and then we should be good to go. Let's invert that, and this looks much better now. Now let's save this as sprite.png. Let's save it as a separate sprite, just to keep the original sprite transparent.png. Okay. And now we can do the following. We can refresh this directory, confirm that's the new and that the transparent sprite is available. And now inside our game, we do the following. We look for the occurrence sprite PNG. There it is. And let's change it for sprite underscore transparent.png. And there we go. This is our game. And we can walk around the game. We can walk around the game. And keep walking. Maybe can we do anything about the background? Which background would look better than what we already have? I mean, this background is fine-ish, but it doesn't look like an action game. We need some kind of something nice. What do we need? No idea. We need to make it look a bit dangerous. I mean, for development, creating this happy game is fine, but how about something more dangerous? What if the floor was something really uncomfortable looking? Some reddish color. That's almost pink. What if we use this one? Something like this. Now this is the floor. And now let's give the floor some detail. Maybe some weird plant that grows there. Yeah. So this is our desert world. And there are a couple of weird plants growing there. Maybe something something like a crooked tree. Like this. And then let's give that some highlight using a brighter color. I don't know. Something like this. Okay, this is our crooked tree. We can give this also more dimension somehow, probably by giving it a shadow or something shadowish. Something like this. Yeah, I mean, that's good. Let's give it a wider base. Okay. And that might be good enough for our game. Let's save that. And the game background has updated. Let's see how that looks in game. And this is our sprite walking around in the background. In the game area. Now I don't really like the sprite's colors, but I think for this video this might be enough. Let me just adapt the color scheming of this sprite. I just want to make one adaptation, and that is change the green color of the body to something else. Let's make this. Let's select the green body. Oh god. Like this. And then let's change the hue. Yeah, that would be not much nicer. Something desertish or something more in this direction. I think this, I like this very much. And then the gray could be brighter, I think, because the player is resembling a positive force in the game, obviously. So let's, or would it be a better contrast if the player was brighter or darker? Let's try brighter. That looks odd, because here the background is transparent, but let's try sprite, transparent PNG. Let's save that. And then, going back to the code and to the compiler, let's also change the hello world printout to welcome to the best game in the world. And let's call the game Sea Fighter. Sea Desert Fighter. Sea Desert Fighter. Okay. And that looks horrible. Of course, the face is way too bright. We can't really make out any facial features here. Maybe it needs some outline. The face needs some outline. I'm almost spending more time here drawing the scenery than doing actual coding, but I think it's quite enjoyable. Like this. Let's see. Oh, wait, we can just use an effect that is present in Photoshop. We can use an outer stroke like this and make it a size whatever 2. Make it black Okay, then let's also draw over the neck here. The eyes maybe. And the mouth, of course. No, that was bad. Okay, we should be done soon. Just like this. That might be good enough. This, like this, like this. Here, give this some thicker black tone. And it looks horrible. Let's highlight the arm as well. Here and here. And also here and here. And the leg. And this leg. Alright. Let's also detail the sword a bit. And here. Okay. Yeah, okay. I think that's good enough. Let's see if it's good enough. If we save this to a file, .png, sprite underscore transparent .png. And let's go back to our game and see how that looks like. Looks shit. This looks really bad. Why does... the feet are cut off, that's why. Okay, that means I have to make this a bit bigger to include the feet as well. Just like this. And this hand should also be included. We can reduce the size here and here on this side. And I think now it might be good. Okay, let's save this. And save that. Okay. And let's run the application. And oops. That's probably good enough, I would say. This transparent PNG has now a dimension 76 by 101 because we adapted the borders. So let's go to the rectangle that defines the size of the sprite. And adapt the values there. So we used the base width and multiplied by 2. So we can use 152 now. And also the same for the height. All right. Then let me scroll to the core of the game, which is the start of this game loop, and execute our game. And that's our game, Desert Fighter in C. I hope you enjoyed it. We can walk around the scene now, which is awesome. We can, replicate some jumping. And this has a ton of potential because now we can technically add movement by updating the sprite to reflect animations. We can add a shadow under the sprite. We can, what else can we do? Yeah, we can implement some game actually. And this is the foundation of how to code a game in C using SDL. And I find it very, very awesome. And I hope you enjoyed this video. If you did, please leave a like and subscribe. This video was exceptionally fun. I loved it. And yeah, there was a lot of different stuff that we did. We did coding, of course. We did the C library troubleshooting. We did some game design here and creating the sprite in the background and making it look, yeah, at least somewhat pleasing. Then we implemented the game loop itself. We learned how to load the graphics in SDL. So there was a ton of content, and I hope that you enjoyed this. And if you did, then please support me on this channel. I would really appreciate it. And yeah, more projects are to come, and see you next time.